Okay, so there has been a request to do a net ionic equations how-to video, so I'm going to walk through one problem with you guys, and hopefully you'll be able to identify your stress points when doing these problems. So in this problem we've got two aqueous solutions that we're going to combine. We're going to combine them and then figure out what if we have a precipitate is going to form, and then we can write the complete and then net ionic equation for it. Okay? So when you approach a problem like this, the first thing you need to realize is that when you're making your new products over here, you need the positive things to bond with the negative things when they switch partners. So we don't want the beginnings to bond, like the ammonium and the zinc will not bond because they both have positive charges, and the PO4 is not going to bond with the NO3 because they don't have opposite charges either. So instead what we're going to see is we're going to have the NH4 bond with the NO3. So we're going to have, that is our first formula, NO3. Now I do have to pay attention to cross-charging. So the charge on NH4 is a positive 1 charge, and the charge on NO3 is a negative 1 charge. So positive 1 and negative 1, they actually balance out, and we're good to go on this problem. So now we're going to write the other product. So the other thing we've got left is the zinc and the PO4. Remember, when you're looking at which one should be written first, you always write the positively charged ion first. And taking a look at the way the formula is written, there's a 2 down here, and that 2 had cross charge from the zinc down to the outside of the nitrate. So we can cross that 2 back up, and that tells us that zinc has a positive 2 charge, okay? And then hopefully you guys have memorized that PO4 is 3-, but if you don't, you can take a look at this. There's a 3 here, and that had crossed down from the PO4, so now we know that PO4 has a -3 charge, zinc has a +2 charge. So when we go to write the formula over here, again I'm writing the positively charged ion first. Remember, zinc has a +2 charge, so that's going to technically cross back down over here. And I don't bring the positive or negative with it, I just bring the number itself. So if zinc had a +2, I cross that down, and so I'm going to have a 2 on the outside of the phosphate. And then phosphate has a -3 charge, so I cross that down, and now I'm going to have a 3 next to the zinc. Okay, so so that's the first thing. Make sure you're doing your cross-charging when you're doing your double replacement reaction. A lot of people will make mistakes forgetting to cross-charge. The second thing people will make mistakes is they'll do their cross-charging, but they won't finally balance the whole equation. So that's the next step we have to do, is balancing. So I've got, let's see, I've got 2 PO4 groups on this side and 1 on this side, so I'm going to put a 2 in front of that. That fixes my PO4 groups. Now I've got a total of 6 ammoniums and 1 ammonium over here, so I'm going to put a 6 in front of that. And let's see, I've got 3 zincs here and 1 here, so I'm going to put a 3 in front of that. And that makes me have 6 nitrate groups, but I think I've got 6 nitrate groups over here. Yeah, it looks like everything's balanced now. Okay, so now I've cross-charged everything, I've balanced the equation. The next thing you would need to do is go to your flowchart and figure out what one is going to be the insoluble compound. So using the rules that I had you guys memorize, the first 2 rules, this one has ammonium and nitrate in it, which are both mentioned in those first 2 rules, that they're always going to be soluble. So this is going to be your aqueous compound for sure. And then if you follow the flowchart, you'll figure out that this one is the solid. Okay, so now we've identified what's going to stay aqueous and what's going to be solid. Okay, now we can move on and do the complete ionic. When we do a complete ionic equation, we want to break everything up into ions that breaks into ions. Okay, so in this case we have 6 ammonium ions, so NH4+, and we have 6 of them, and they're aqueous. Notice I'm including the number of the ions, the charge on the ion, and the state, okay? And now we've got 2 PO4, 3-. Okay, and there's 2 of them, so I'm going to put a 2 in front of that. Notice I'm getting the charges. Again, if you don't remember how to find the charges, you can do some backwards cross-charging and figure out charges, okay? Alright, so we've got 3 zincs, And the zinc has a 2 charge. Okay, that's going back up, so 2 plus on the zincs. And then 3 times 2 is 6 nitrates. Okay, so that's it for the reactant side. On the product side, this is still an aqueous compound, so I'm going to keep it broken up into ions. Including the state still. And then I've got 6, remember the 6 travels to the other part of the ion as well, or the other part of this compound. Okay, and I don't think my solid's going to fit, so I'm going to write it underneath, zinc 3p. 2 solid. Okay. And notice I didn't break the solid up because the solid, when it actually reacts, stays as a solid. It doesn't actually break up into ions. So we don't need to break it up into ions in the complete ionic equation. The next step is to get rid of the spectator ions. And these are the ions that are the same on both sides of the reaction arrow. So our NH4 stays the same on both sides, so I cross those out. My NH3 stay the same on both sides, so I cross those out. And what I should be left with are just the ions that participated in making the solid. So I've got this and that, which they did come together to make our solid, so that's how I know I've done this correctly. Okay, and then I can just recopy those things into the net ionic equation. So the net ionic, you've got 2PO4, 3 minuses, plus 3 zinc, 2 plus. I made a mistake up here. I didn't include the state. Okay. And then that made zinc 3 PO4. Alright, cool. So I can double check that I did this correctly in that I've got a complete balanced net ionic equation. So 2 PO4s, 2 PO4s, 3 zincs, 3 zincs, and I double check that I've included the charge, the number of the ions, and the state for everything. Okay? And that looks good. So I know I've done it. Alright, so good luck to you guys. Don't forget to do those cross-charging. That's the really important part that people will forget. And if you're still having struggles with this, come talk to me soon. Okay? Have a good one.